Hello and welcome to the Southwest Regional Mock on YouTube. Um, Today we are going to be looking at the third episode on the paper, which I've decided to select question number 10. This question was on numerical methods as well as existence of roots. We have volume calculation when a curve or the area bounded by a curve being rotated about an axis, and also equation and logic. Now, please, if you are new to my channel, kindly hit the subscribe button and also don't forget to turn on the notification bell so that when new content are released, you will not miss it. That is when I upload a new video, you will be the first to be notified and you easily watch the content. Please, as you watch this video, make sure you watch alongside with a piece of paper so that whatever activity I'm going to be doing here, you do exactly the same thing, because just by watching the video you're not helping yourself as a student. So kindly watch the video with a pen and a piece of paper beside you, just to even be writing down some few things. Also, you should note that you should also share the video. After watching the video, make sure you share it so that it can also go viral. So without wasting much of your time, let's get straight into the presentation proper. So the first question is asking us, we are given a function f of x which is equals to x minus 5 plus x squared ln x. We have to show that the equation f of x equals to 0 has a root or a 0 in the interval 2, 3 excluded. That's x between 2 and 3, 2 marks. So let's do that one first. First of all, we have our function f of x. Now, to show that this function has a root between 2 and 3, we are going to calculate the value of f of 2 first. When we calculate the value of f of 2, we found out that it is equals to 4 in 2 minus 3, and this is approximately equals to minus 0.227, and this value is less than 0. Anything negative is less than 0, right? Okay. Now also we are going to calculate the value of what? F of 3, and f of 3 gives us what you have here, 9 ln 3 minus 2, giving us a value of 7.88875, and this value is strictly greater than 0. So we see that since f of 2 and f of 3, they have opposite sign, this one is positive, this one is negative, it shows that the graph of f of x must have crossed the x-axis between the abscissas x equals to 2 and x equals to 3, which shows that there is a existence of a root between 2 and 3. So that's our conclusion. We have that since they have opposite signs, it implies the equation f of x equals to 0 has a root in this interval. This is what you're supposed to do for the first part. Now, let me just show you what I'm saying graphically. This is not the curve of this function that I want to show you now, but it's just an interpretation of what I was trying to explain to you. If it is so, if you cannot get it directly from there, so this is what I'm saying. If you have let's say our axis given x and y, then we have this curve. We see that look at this point. uh, we have those two abscissas a and b. Looking at this point here, we see that the value of the function is right up here. So if you extrapolate like this, you have a positive value, right? This above the x-axis. Now the value of f of b, which is here, it is a negative value. That's why I found below the x-axis. So this shows, you can see clearly that since one is positive and the other one is negative, the curve has crossed the x-axis between a and b. So this is exactly what we were demonstrating here, that you see now that they have opposite sign, it has crossed the abscissa, the x-axis, right, between the abscissas A and B. So there is a root between A and B. This is what we have just done here. Okay, this is what I was explaining graphically now. So let's move to the next part of the presentation, which is on Newton-Raphson's approximation. So getting to that, please, I see emphasize, if you have not yet subscribed, go and subscribe, and also share the video. I hope you are enjoying it. Okay, now the question is asking us that taking x equals to 2 as the first approximation to the roots of the equation f of x equals to 0, use one iteration of Newton-Raphson's procedure to find a second approximation to this root, giving your answer to 2 decimal places 3 marks. So according to Newton-Raphson, if x this is what he's saying. If xn is a first approximation, then a better approximation is given by xn plus 1. This is a recursive definition. Sn plus 1, which is equal to Sn minus f of xn divided by f prime of xn. And this formula holds only when this denominator is not equal to 0. If the derivative of the function at xn is equals to 0, then we have to choose a new starting value. Okay, now from what we have been given this, that taking x equals to 2 as our first approximation, which I will decide to call x0. So if x0 is our first approximation, then a better approximation now will be what? X1. That's replacing n by what? That's 0 plus 1, it gives us 1, right? So replace n by 0, that will give us x1 equals to x0 minus f of x0. That's replacing n by 0. That's our better approximation. Remember, our x0 is 2. So you see that in the formula we will need a derivative of the function, and we know f of 2. We have calculated it in the first part of the presentation. So let's calculate the derivative of this function. When you differentiate this x, you end up with 1. When you differentiate negative 5, it is a 0. Since it's a constant, you don't write it down. Also, to differentiate this now is a product of two functions, x squared and ln x. So to differentiate this, we use the product rule of differentiation. That's you whole x squared and differentiate ln x. That will give us what? X squared into what? 1 over x, right? And x squared divided by x will give us an x, which you can see here. Then also now plus, you now whole ln x and differentiate x squared. When you differentiate x squared, what do you have? 2x. Then ln x, the one that you kept constant. I'm applying the product rule there. So once you have had this derivative, all we need to do now is to look for what? F prime of x0, right? First of all, we know that f prime of x0 is equals to what? F of 2, since x0 is equals to 2. So I just replace 2 here anywhere I see x, and that will give me a value of 5.772. And then now, going further, we know that f of 2 is equals to this, right? What we did in the first part of the proof. Then also, from this now, all we need to do is just to replace in the formula. That is, we replace x0 is equals to 2, f minus, this is a negative, f of x0 is f of 2, which is this, you put it there, and the f prime of x0 is 5.772, and you just punch this into your calculator. That will give us a value of 2.04 corrected to 2 decimal places. So that is exactly what you're supposed to do to this to earn 3 marks. Okay, getting further, we have that we have to find the volume generated when the area of the final region enclosed by the x-axis, and the x-axis is the line y equals to 0, and the curve, this, right, this curve is rotated about the x-axis completely. So the first thing we begin by looking for the limits of integration. Thus we equate the function y to 0 and solve for the limit of integration. That is what we have, x minus s squared equals to 0. Having that in mind, all we need to do is to factorize this. Since s is a common factor, we factorize that, we have x into 1 minus s squared, x equals to 0. Now, when you solve this quadratic, you end up with x equals to 0 or s equals to 1. So those are our limits of integration. Now, our volume of solid generated is pi integral from 0 to 1. Those are the limit of the function square dx. This is because this like a rotation about a line y equals to 0. Y equals to 0. This normally was supposed to be what? Y minus the line, right? Y1. Y1 here is 0. That's why we just have y squared dx. Normally, when it is rotation about the x-axis, it remains like that. Now, from there, we need that in the formula, we need the formula x squared, y squared, the value, the expression for y squared. So we just have to square this value that we have here, this expression, and when you expand this, you have s squared plus 2 times the product. When you multiply this, you have minus x cubed times a 2. Then now you also square this, right? That's the expansion of a minus b all squared. I hope you remember that. With this now in mind, we have just to replace this here in the formula, and upon integrating, that will give us when you integrate this, you end up with s cubed divided by 3. Integrating this, you have what? X to the power 4 divided by 4. 2 on 4 gives us a half, and x to the power 4, when you integrate that, you have x to the power 5 divided by 5. And now all we need to do is what? Put the limits of integration from 0 to 1. Replacing 1 in this expression, that's the upper limit minus lower limit. Upper limit gives us 1/3 minus a half plus 1/5 minus the lower limit. When you put 0 here, everything will become 0. That's why I wrote 0. Then now simplifying, that gives us a value of pi on 30, which is actually cubic units since it's a volume. So that's the volume of the area or the solid generated when this area bounded by the x-axis and the curve this is completely rotated about the x-axis. So let's get to the last part of the presentation. This one was for 4 marks. Very easy, right? Now, getting to this, we have equation on logic. We are given that P, the statement P and Q, where P, Mark obeys school rules, and Q, Mark will be punished. Mark will not be punished. They are the two statements. We are asked to write in ordinary English the statement in negation of P or Q, 1 mark. So we are going to use the De Morgan's laws, which says the negation of P or Q is equals to the negation of P and the negation of Q. So applying it to this our case, this one will now be the negation of this statement here. That's the negation of P and the negation of Q. And now double negation gives no effect, keeps the statement unchanged, and the negation of Q. So this statement reads that what? This is what it reads. Mark obeys school rules and he will be punished. Mark obeys school rules. That's the statement, right? And then the logic and you put it there. Mark obeys school rules, and now the negation of Mark will not be punished is Mark will be punished. So we read Mark obeys school rules and he will be punished. That is all I have for you guys. Please share this video so that I can go viral, and also please don't forget to subscribe. Don't be selfish. When you are benefiting from my content, you should not you should also support me by subscribing and sharing the video to others. Share to your friends. Don't be selfish. Knowledge is power. Just share, keep sharing, and ask them to also share. Bye bye. See you in my next episode. I love you all.